All right, so here we're going to graph a rational function and run through the entire process of doing this. And I'm going to give you this rational function already in factored form. And so there it is factored before you. So let's just run through the steps to graph this. So step number 1, find the y-intercept. And of course we do that by plugging in, evaluating the function at 0. And so if you plug in a 0 into that function, you are going to get, 2 on top, so 2 over negative 8, so negative 1/4. So our graph is going to go through negative 1/4 on the y-axis. So we'll keep track of that. Next, let's find the x-intercepts. And those are the zeros of the numerator. And because this is factored already, we can write them down, just reading them off. So we're going to get x equals 1 twice, because x minus 1 is a repeated factor. And then we're going to get x equals negative 2 once. So 1 has a multiplicity of 2, which is even, and negative 2 has a multiplicity of 1. Now we use that multiplicity to classify these, the behavior at these intercepts. Remember, if the multiplicity is even, if the 0 or the factor shows up an even number of times, like the x minus 1, it shows up twice. That tells me that that 0, 1, the graph is going to bounce off of that. And so we want to, at the same time, just put a little b here to remind ourselves that we're going to bounce off the 0 or the x-axis instead of going through it. Now, negative 2 comes from this factor, and that factor only shows up once. 1 is its multiplicity. That's an odd number. Odd multiplicities are going to have the behavior where the graph goes through those zeros or those intercepts. Step number 3, we want to find the vertical asymptotes. And those occur at the zeros of the denominator, which we can read right off. X equals 2 shows up once, x equals negative 1, and x equals negative 4. And each of those have a multiplicity of 1, and so we have a way of classifying the behavior at the asymptotes in kind of a similar fashion to what we did with the x-intercepts. If the multiplicity is odd, which is the case for each of these vertical asymptotes, then we know that the behavior of the graph near that asymptote, it's going to go to positive infinity on one side and negative infinity on the other. And so we classify those, we call those kinds of asymptotes opposite asymptotes. The graph's going to go up one side and down the other. If the multiplicity had been even, then we would classify them as the same type of asymptote, meaning that the graph goes up one side and up the other, or down and down, or to infinity and infinity, or to negative infinity and negative infinity. But all of these are opposite asymptotes. And so that will help us graph this graph ultimately. Lastly, we want to find the horizontal asymptote. And remember, to do that, we look at the degree of the numerator versus the degree of the denominator. And so these are factored, and so it might look like it's a little bit complicated to figure out what the leading term is, but we can do it. The leading term is going to be obtained by multiplying the first term in each of the factors. So on the top, it's going to be the x from the x minus 1, and then the x from the other x minus 1, and then the x from the x plus 2. So x times x times x is x cubed. If we were to multiply the entire numerator out, the leading term would be x cubed. Likewise, in the denominator, we take first times first times first terms to get the leading term. X can multiply to give us x cubed. So, of course, that's x cubed over x cubed. Now, there are a couple ways to determine the horizontal asymptote. One of the ways we talked about was to simply reduce the leading term over the leading term and see what you got. So if I reduce x cubed over x cubed, that is the number 1. That is my horizontal asymptote. Another way to do it is we have a little kind of a little flow chart of rules that says if the degree of the top is equal to the degree of the bottom, then what you do is you take the ratio of the leading coefficient. So in this case it'd be 1 over 1. 1 over 1 is 1. So whichever way you use to find this horizontal asymptote is fine, but the horizontal asymptote is going to occur at y equals 1. Okay, so now we're ready to sketch in the key parts of our graph. All right, so let's just start at the top. Our y-intercept is at -1/4. So we're going to go down to -1/4 on the y-axis and put a point. Our x-intercepts are at 1 and -2. So we're going to put in intercepts or points on the x-axis at 1 and -2. Remembering that we've classified those as, and let's just put that in there too, the graph is going to bounce off 1 and go through 2. Then our vertical asymptotes occur at -4. So we can draw this. At -1 and at 2. And we have those classified as well, and they're all opposite, so the graph's going to go up one side and down the other. Lastly, our horizontal asymptote is at y equals 1. Now, with the horizontal asymptote, as soon as you put it in, what you want to do is put in the left and the right ends of the graph. So you know the graph's going to become asymptotic there. Now, we don't get quite detailed as to whether the graph is above or below, but it's good enough to say, all right, the left and the right parts of the graph become asymptotic to that line. So at this point, what do we know about the graph? We know that it goes through this point, it goes through this point, and it bounces off that point. So it touches that point. We also know that the left and the right parts of the graph are there and there. With that information, we should be able to sketch the graph. So let's do that. And we're going to start, let's start in the middle. No, let's start on the left, because we know the graph is right there. So we can just pick up from right there. So the graph is going to be there, and as it approaches this vertical asymptote, it's got to go up or down. Now, we talked about how to determine whether it goes up or down. In this case, it must go up, this asymptote. The reason being is because if it were to go down, it would need an x-intercept right there to cross, and there is none. So it must go up, otherwise there would be an x-intercept there. So it goes up that side of the asymptote, and because this is an opposite type asymptote, it goes down that side. And then it's going to come back up to this x-intercept, and it's going to go through. And then it must go up this side of the asymptote, because there's no way for it to make a U-turn and go down. So it goes up that side. Well, that means it goes down here, because that's an opposite type of asymptote. And then it's going to go through the y-intercept, hit this x-intercept, and remember, it doesn't go through, it bounces off, which means it must go down this side, up this side, and then let's just finish it off by making the right in behavior asymptotic there. And there is the complete graph, and you can check that versus a graphing calculator.